Yeah. Why do you do that, man?
These are all wrong.
Why are they wrong?
Because the surface of the Earth is made of more than one mini plates.
Oh,
And they're all moving very slowly.
gosh, how did I miss that?
There's the plates have all moved greatly over time. So they're not nearly identical to millions of years ago.
Oh.
Topographic maps also display in difference in lines, not just color.
Mm-hmm.
Mountains are created also by convergent boundaries.
Mm-hmm.
And it's not the only evidence. They've also found fossils of the exact same animal on different continents.
Wow, thanks, Espejo.
You're welcome.
A plate boundary is where two plates come apart or come together. A good example of these plates coming apart is how Pangaea deformed into the continents that we know today.
Because the plates are always moving, there are no stale boundaries. Since there are no stale boundaries, they're convergent and divergent boundaries. A convergent boundary is a place where two plates collide. The collisions can form subduction zones where one plate goes over the other, or they crash and they can form mountains. Divergent boundaries are where plates are going apart like this. An example of divergent boundary is the Mid-Atlantic Ridge.
The definition of pressure is exertion of force upon an object. It plays a huge role in plate tectonics. Plates in the crust would not move or be still if pressure in the mantle formed by convection currents were to be non-existent.
The focus is the point where the earthquake began under the earth. The epicenter is the point directly above that on the land. A topographic map is a map used to show elevation. Some topographic maps use color to show elevation, whereas others use lines to show distances between different. Tectonics is the theory which describes the large-scale motions of the plates. Plate tectonics was first proposed by Alfred Wegener and first accepted by the scientific community in 1950.
Wegener discovered that the continents seemed to fit together in something that he called Pangaea. Pangaea, this giant supercontinent. Pan meaning all, and Gaea meaning land.
In this lab, I will be showing you how to interpret a topographic map and how weathering can affect the topography of a region. In this lab, you will need two differently colored Play-Doh buckets and a ruler. You will need to stack 0.5 centimeter thick Play-Doh layers until there are 6 Play-Doh layers alternating in color. Next, you will need to set up your 3 topographic maps, each with a key with 0.5 centimeter intervals per line. Then you will need to take a ruler and cut a 1 centimeter deep incision and dig your Play-Doh stack. Next, you can use your ruler and your hand to separate them so you can get a better angle to look deeper inside the topographic map. As you can see, there is one visible yellow layer and one visible green layer that you've cut into. This is a total of 1 centimeter thick since each plate is 0.5 centimeters. Now you can draw your topographic map for the first 1 centimeter thick incision. After you have your map, which should look something along the lines of this, you will need to draw your intervals. Since you have 0.5 centimeter intervals, you will then need to draw a line for each Play-Doh layer that you incisioned into. After doing this, your topographic map should look something along the lines of this. The next step is then to do another 1 centimeter thick incision into your Play-Doh. After doing this, you can split apart the Play-Doh to better see the inside. So now, after that incision, there's 1, 2, 3, 4 visible 0.5 centimeter thick Play-Doh layers. Now you will need to draw your second topographic map, which after the floor, you'll need to draw your incision, which should look something along the lines of 1, 2, 3, 4. Now you can see that there is 1 yellow, 1 green, 1 yellow, and 1 green visible layer, each 0.5 centimeters thick. Next, you will need to make another 1 centimeter thick incision, and that should bring you all the way through your Play-Doh. So after this, you can take one side and look at it. Now there's 1, 2, 3, 4, 5, 6 alternating layers. You will need to draw your third map, topographic map, with 6.5 centimeter intervals. To be able to tell which way your topographic map is pointing, so you can know it's a canyon as opposed to a mountain, you'll need to draw your total depth, which is -3 centimeters, so they know that it's not a mountain. And then your outside, your biggest layer needs to be 0 centimeters, because originally it was the top of the land that we cut into. And then we can cut here, and then we can say conclusion.